Even just a few years back, I used to be amazed about the rapid technological progress we've been going through. These days though, I often find it tiring that things I bought 5 years ago and that were cutting edge back then are now almost obsolete. And we've all been through this. You buy a new phone, you take it out of the box, boy, it sure is the most awesome thing ever, with a great camera and all those new features. And just a few years later it appears to be just as boring as any phone and also obsolete, and we really need a new one. And that's why I currently try to focus on buying and maintaining objects of lasting value. My lathe, for example, that I've put to use in my last episode is 100 years old and still serves a purpose. So, in that sense, let's see if we can find any objects worth saving on the scrapyard and take them back to the workshop. The first item I found today is this cast steel vise here, and I'm buying that. I know I find a lot of vices these days, but that's simply because they were built to last. Here is some kind of old trailer hitch, and I'm buying that as well. Over here is the air tank of a Kesa brand dental compressor. Very expensive. Unfortunately, someone has already taken off the actual compressor pump. A really old Miele washing machine with a huge motor, but I already have a few of those on my shelves. This thing over here is a Cobalt brand lighting tripod, another keeper. And down here in the rain, another rusty old vise. I keep finding them and I can't resist. So of all the items we found here today, the vices turned out to be the only items that really needed repair, and that is why we're going to focus on those two finds, plus some work on another vise we found at an earlier time. Let's get going then. Let us first take care of this vise here, because I believe that it will be a way easier repair before we will face much greater challenges in this video. This vise doesn't state the manufacturer and has no logo, but it says Stahl on one side, which means that the vise was made from cast steel, which is rather rare. But I'm going to say a little more about that in just a minute. Let us first restore it. I'm starting by applying WD-40 to all moving parts, and I let that penetrate for a while. I also remove rough dirt with a wire brush and some steel wool all around the slide. The dirt could otherwise hinder the slide from moving back or even scratch the surface of the slide. After clamping down the vise to the workbench, I try to turn the screw with the goal of completely detaching the sliding jaw from the body of the vise. I do that in order to remove the rust and dirt from those parts separately then. Unfortunately, I can't move the slide any further than this, no matter how much force I try to apply manually. I then removed screw and handle, and since the vise is already opened to this wide degree, I was able to fit this heavy-duty hydraulic jack between body and sliding jaw. I had tried this before with a 3 and an 8-ton car jack, and both gave up at a certain point. I believe this one is rated for 20 tons, and eventually it was able to push these parts apart. Despite the enormous forces that were needed to separate these two sections, there is no real damage to the slides. It's apparently just the power of rust at work. And after removing some of the dirt and humidity manually, the vise is wire wheeled with an angle grinder all around at all accessible spots. I do this stuff all the time and I can only stress how important it is to at least wear protective glasses, but also use a good, smooth running angle grinder and also a well-balanced wire wheel. You wouldn't believe how painful and harmful the vibrations from an unbalanced, uncontrollably vibrating grinder are on the long run. Especially cheap wire wheels are a problem. The handle is clamped into this pipe vise that we restored in an earlier episode. When working on these round workpieces, it is a real time saver. And after everything has been wire wheeled, I cleaned the surfaces additionally with some alcohol. And now I have taped all machine parts of the slide, the screw and faces or jaw plates with tape, because the vise is about to be spray painted and those parts simply don't require any paint. After around 2 days I have removed the tape again, weighs and screws receive new grease, and the slide and screw are reinstalled, and also the retaining plate holding the handle is screwed back on. The slide is now moving with incredible ease, and this is actually a really cool score, a rare vise in really neat condition. All that is really missing is one screw, and I guess I will just have to find a replacement for that then. A friend also found this old advertisement here from a company called Tücking. It advertises this very similar looking tool as a Stahlguss, meaning cast steel vise, and that is rather rare in itself. Most vices are made from cast iron, and some, like these ones here from the last episode, are made from forged steel sections, but cast steel is rather unusual. The letters DRGM are an abbreviation meaning as much as Utility Model or Small Patent of the German Empire, Deutsches Reich Gebrauchswarenmuster, and this means that the vise was at least made before 1945. Since we are working on some vices here and spray painting them, I thought why not do a little refining work on another vise that I repaired in an earlier episode. This here is episode 21 of this series. All other episodes can be found down in the video description. This particular vise was once also a rusty piece of trash, and we repaired it back in episode 11. Back then I did a brazing job on it, and you can see this brass seam here that is used to attach a steel replacement part to the cast iron body of this massive tool. Today I have ground and polished that part as preparation for the new paint job. After taping various sections, I apply that paint all over that vise as well. And again, after a day or two, we can put it back together. Nice to see how it almost appears to be made from one piece again. But this was just a minor aesthetic measure. We will now face a much more complicated array of repairs. Let us take a closer look at this rusty old vise then. I'm spraying it with some WD-40 in the hopes that it will help loosening the old sliding jaw at least somewhat. Quite obviously, a large piece of the base has broken off alongside its side. We will have to replace that entire part, and that will be a lot of work. And right beneath the face of the sliding jaw, we can also see what appears to be an earlier welding job, which isn't looking particularly nice, and I will have to look at that as well. On the flip side, we can find the logo of the manufacturer, but I say we inspect that closer once we have cleaned the vise. I will start the repair by attempting to unscrew the sliding jaw, and in order to hold our workpiece in place, I'm employing another vise that we had repaired back in episode 13. And since the handle is also missing from the screw, this is a rather tedious process, even though I have to say that the jaw is moving much easier than I first expected. Upon freeing the slide, I can attempt to remove the screw from the inside. For that purpose, I have to also unscrew the little retaining plate that holds it in place. A piece of this part has broken off at some point as well, even though it's obviously still doing its job. This part here in the back is basically the main nut. It is bolted to the body of the vise, and this is where the screw is inserted, pulling the two jaws towards each other. And we find really nasty old grease all over that part. The same is true for the insides of the body, where that nut was installed before. In fact, the entire surface of the vise is so dirty that this time I start to remove grease, grime and dirt manually before even starting to wire wheel. The reason is that the wire wheel will get super dirty and grimy itself. It would also needlessly spray that stuff on the walls and windows around me. For dirty and rusty workpieces with recesses that are otherwise hard to reach, a small wire brush in the form of a paintbrush comes in handy. Greasy dirt can be wiped off relatively easily when you also apply a solvent of some kind. For example, paint thinner, gasoline, or as in this case and less aggressively, WD-40. We can now begin wire wheeling all the parts, and I'm doing that once more with my big Bosch angle grinder that I found on the trash around 10 years ago. And I think that it must have been 30 years old already at that time. While removing the rust from this spot here, we find even more damage. It appears though that these holes in the cast must have been there from the very beginning, meaning that they were probably created during the casting process. We'll try to repair that anyway though. While removing the rust, we can also have a closer look at the logo, and it is apparently upside down. I don't know what you think this logo is supposed to represent, but I would read this as the capital letters R and E and then CO, probably for company. So R-E-C-O. but I was so far unable to find a manufacturer going by those letters. What do you think the logo says? Leave a comment below. Independent of the particular manufacturer, this design style of vices is known as Systemkoch, which means System Koch here in Germany. And many different manufacturers used to build vices of this type. But be that as it may, I proceeded with the wire wheeling process until all accessible rust was removed. It is now time to prepare the workpiece for the major brazing job that will be necessary in order to add a new mounting bracket to the bottom of the body of this vise. What I want is a clean straight cut through the cast that will allow me to fit a custom-made piece of steel to the base. In order to make that possible, I'm cutting through the cast iron with an angle grinder. What looks like easy and quick work here is rather tedious in reality and requires some experience with angle grinder work. I also can't cut all the way through without damaging the cast and other spots. That's why I also cut these perpendicular slots here. They can just be punched out with a hammer. You wouldn't be able to do this with a vise made from forged steel. This is only possible with cast iron, which is way more brittle in nature. A file is then also used to get a cleaner result. But we are going to braze this with brass. And the brace needs a certain thickness to be strong enough, and that's why I'm using yet another angle grinder to, well, grind an angle into this edge. You will see the reasoning behind that in just a minute. In order to be able to actually make a new bracket, I had to return to one of the scrapyards where by now it had started to snow. This piece of steel here is just what we needed. After taking measurements and marking the outlines on the steel, we used the big Hilti angle grinder we repaired in another episode to cut through the thick material. At the drill press, new mounting holes are also added. And then, among other tools, an old bench grinder is used to round off the edges and bring this workpiece into a shape that will fit right onto the vise. And then I'm grinding angles into these edges here as well. And the idea is that these adjacent slopes alongside the edges of our workpiece will form channels for the brass to flow into. This is actually already looking pretty good. But before I will begin to preheat the vise for the brazing process, there's another spot that I have to prepare. I'm sure that these holes here were created when this casting was first made. I will attempt to fill those holes with brass and then grind it down to the surface level that this tool was supposed to have in the first place. But I'm not going to just braze over these spots here. I rather try to grind down the faulty material with a Dremel until I have reached bare cast iron everywhere. But before the brazing can begin, our new mounting bracket will have to be fastened to the vise in such a way that it will already be correctly aligned once it has heated up, so that I can proceed brazing, which is also a race against time, because the workpiece will cool down while you work. There is no time to align the part once it's hot. Two pieces of steel L-bar are bolted to the mounting holes. But because the mounting brackets of this type of vise are not supposed to form a perfect plane, but rather form a slightly angled V-shape, some washers are also placed between the bars and the bracket to set the correct angle. Now the forge is fired up, first with a little wood fire, which is then more and more replaced by blacksmith's coal. I also move the vise around in order to allow for more even heating of the workpiece. An oven with temperature control would be better, but this forge that we also built from scrap in an earlier episode will have to do here. With the vise heated up, I fire up the oxyacetylene torch and start brazing the bracket to the vise, starting with the bottom seam, or at least a part of it between those two L-bars that I can reach at this time. The idea here is to first attach the bracket somewhat to the vise so that I can later remove the L-bars without the entire piece falling off. In the next step, the holes that we ground down with a Dremel are filled with brass. After this is done, I am wrapping the vise into a heat blanket and take it inside. in order for it to cool down very slowly overnight. The brazing job is not yet done. This is just an intermediate step for me to check if the brazing attempt of those holes worked properly. It is 70mm thick cast iron at that spot and very hard to heat up properly. The seam on the bottom side might look a little rough, but it has made a good connection with both the cast iron and the steel, and there are no cracks, bubbles or enclosed materials in the brass. The brass filling those holes is still covered in a certain amount of slag, but we proceed by grinding it down with an angle grinder. And this is the result of the first attempt. It is not perfect, but it has actually worked to around 90%. But we have to heat the vise up again to finish the brazing job on the bracket, and I will also try to rework the other brace as well on the second day. And I brace the upper seam and later remove the L-bars completely and both rework and complete the lower seam and apply brass all around the edges of the two now joined workpieces. Now I have talked about this before, but it's been a while since I showed this in a video and there will be questions. Why brazing and not welding, and what's the difference anyway? Well, to make it short, brazing, in German Hartlöten, meaning hard soldering, means to connect two workpieces with a solder that melts at a temperature lower than the melting point of the workpieces, while welding involves temperatures high enough to actually melt the workpieces, in this case iron and steel. This also means that brazing is less aggressive than welding, and when welding cast iron you always run the risk of making the cast iron super brittle, essentially destroying the workpiece. And brazing has another advantage here. We can use the brass as a third medium to connect cast iron and steel together. And even though I really would like to be able to do that, I'm not really able to create cast iron replacement parts. I can only make them from steel. And that's the second reason why I do this by brazing with the oxy-fuel torch. In German, Hartlöten mit dem Autogenschweißgerät. And what can I say? This work is excruciating, probably unhealthy, and also expensive. Don't even ask me what the brass filler alone cost me. But it sure as heck is also fascinating work that has an almost magical quality to it, at least for me. After I'm done with the brazing, our patient is again wrapped in that welding blanket. And I'm only resuming my work the next day, since a slow cool down is also key when working on cast iron. After the cool down, the brazed workpiece will still be covered in flux residue. That still needs to be removed, and I have already done that off camera here. I really used a lot of brass here, but a braze on a vise should probably be as strong as possible. On the bottom side, I had to grind the braze down to match the original surface of the vise, and from what I can see I would say that the brass has made a really good connection to both steel and iron all around. But before the vise can get a new paint job, we still need to take care of the sliding jaw part. There still is that spot under the face of the jaw that looks as though someone had welded it at some point. I won't take the face off because that could only lead to more problems, like breaking off the bolts. Instead, I'm simply taking away some of that welded on material to reshape it to a form closer to the original. With that being done, I'm preparing the entire vise for a new paint job. I'm again covering various surfaces with tape to protect them from the paint. I'm waiting at least one more day for the paint to dry, and that time always varies with the type of paint and the surrounding temperature, of course. I decided not to spray paint the brass itself. There would be no point in trying to cover up the repair. I thought I'd rather just make a statement here and show that this vise is not new, but that it can still serve a purpose and that I went out of my way to make that possible. But before I can really reassemble the vise, there is still one more thing to take care of. The missing handle. Now normally I would just drive to a nearby metal dealership, buy a piece of round stock and maybe forge a new handle from that, but because of a lockdown I can't do that. All I have is this hexagonal chisel from the scrap. It's from a demolition hammer and it's made from hardened steel. It should do a good job. I'm firing up the torch again, and then I use my old blacksmith's vise, the first of that kind that I ever repaired, to make a new handle from that chisel. It's not perfect, but it's the best I can do on short notice here. And one thing is certain, I can't keep all the items I repair here, but I will keep this one to remind me of all the work that went into its repair. Those were the repairs I had in store for you today, and I really hope you enjoyed to follow me along. If that is the case, please give the video a like to give me the clear sign to go full steam ahead with more episodes like this. I also promise that future repairs will cover a variety of different tools and machines, both mechanical and electronic, just the way it's always been on this channel. If you want to support me in making new videos and the ideas they represent, please consider becoming a supporter on Patreon under patreon.com/tpai. Or make a donation via PayPal. Links down in the video description. See you soon.